There we go. Next we have Colin Faber. Colin's senior staff engineer at Seagate in Golden, Colorado. He was the original CFS engineer working on Lustre. He has over a decade of community involvement. He helped construct some of the largest file systems on the planet. His current role is product architect for the A200 Policy Engine system with focus on Policy Engine technology, specifically Robinhood. Ladies and gentlemen, Colin Faber.
Hi, everybody. We'll skip this one because you just heard what Robinhood is. But how do we utilize Robinhood at Seagate? We use it directly in some of our product offerings, including our A200 object store, as well as our cluster store L300 and 9000 and 1500 systems. Currently, it's deployed on large-scale file systems supporting hundreds of millions of files, as well as huge amounts of daily activity, file change rates and whatnot. Primarily, we use it for HSM-related tasks, as well as stale file detection. And for the most part, we're fully committed to improving both the performance and reliability of Robinhood, as we see it as a vital part of the Lustre ecosystem. Some of the challenges that we've run into while utilizing Robinhood have been primarily around the database itself. We have had some issues with Lustre change logs. We've tried to address those as much as we can, as well as incorporating any changes that the community may be providing. When dealing with Robinhood, for the most part, we found that our problems aren't so much related to Robinhood's performance directly, but the database backing Robinhood. Most of the things that we've seen are the transactional process of Robinhood tends to be somewhat inefficient, and that isn't Robinhood's fault. This is within the database itself. One of the things that we'd like to try to do, and we've started doing, is exploring alternative database technologies such as Percona's TokaDB engine, as well as PostgreSQL and others. Some of the things that we've tried to do to mitigate the challenges that we've run into within Robinhood itself, and specifically dealing with the database, is code improvements for manageability. One of the things that we noticed when we started working on Robinhood was many of the core functions of Robinhood are quite complicated. We have single routines which encompass many different functions. So what we tried to do is break those routines up into logical blocks to make it just a little bit easier for us to begin to try to tune and test with. Part of this is introducing a development package as part of the Robinhood package to allow for development against this new core that we're working on. We've run various database tuning experiments as well as Lustre tuning experiments, and we've developed our own value-added plugins for the core ingester. The other thing that was critical for us for any of these large-scale deployments was determining the appropriate sizing for a policy engine. There's some hints out there and some documentation out there which will suggest that you do this or that, but for the most part we found that we had to test quite a bit to determine a piece of hardware that would adequately support the scale of the file systems that we're dealing with. So one of the things that we found when sizing a system is, most of the system, as I said, is relational database. Each inode on your system, each request will result in 4 or more transactions to the database. Right? These are different tables in which each one of those inodes is stored in some way. At least this is what we found. Running reports and triggering policies, utilizing any of the external tools provided by Robinhood, generally generate complex queries which can hurt the database or slow the database down considerably. In some cases on very large file systems, we found that some of the reporting tools within Robinhood would take days to return a result. We've also found that, of course, low power, low core count, slower policy engines, which is what we started with, tend to result in slow policy engines, which is generally unacceptable for customers dealing with extremely large file systems. The larger scale machines that we then moved on to testing with, indicated much better performance, obviously, and most of the performance issues, again, were not within Robinhood itself, but within the database backing Robinhood. One of the things that we discovered right away was that the database tuning that we were doing was only slightly better than the tuning that you can get from Percona with their tuning wizard. So if you guys are looking to possibly improve your tuning, or if you haven't done any tuning on your Robinhood databases, this is a fantastic tool. We found that, again, that our tuning efforts were only slightly better than what the tool was producing for various values for the database. Another very useful tool here is utilizing Sysbench. Sysbench provides OLTP complex tests. These tests do a pretty good job simulating the kinds of loads that we typically see in a production Robinhood environment. The nice thing about this is the test can be run over and over again. You can avoid any of the potential overhead that Robinhood may be introducing or anywhere else in the chain. So upon testing various CPU levels and stuff, we found that, of course, faster CPUs are better. With the database in respect, we found that multi-core, high gigahertz-based CPUs tend to provide the best kind of performance out of the system. The slower CPUs and the lower powered CPUs tend to kind of fall off. CPU core count itself doesn't matter too much. Once you get above about 12 cores, we start to see relatively same performance between the CPU, and that's where the actual speed of the CPU is very important from the standpoint of cycle rate. The lower power CPUs do tend to do all right. However, when you're building your system, typically the way we began to look at this is we're building a large-scale database server, and then we're tacking Robinhood onto it. When you're sizing a system, of course, again, CPU is the most critical bit. Available memory helps a ton. The more memory, the more the relational database we can cache in memory, which helps, of course. And your storage subsystem should be appropriate for the file system size itself. We found if it's about 1 kilobyte per inode plus the NODB log size, whatever you have that tuned to, gives you total size on disk. For us, we tried various configurations with both disks and NVMEs. We found that, of course, the PCI Express NVMEs perform the best with high IOP rates over the long term. However, we did utilize various disk-based systems and found we could get reasonably good performance out of those as well, assuming you've got enough memory on the system. We've also chosen ext4 for our file system, backing the database, because we found that being the most performant out of the various file systems we tried. However, the variations in performance were 1% or less. So, whatever your favorite flavor of file system is. When tuning a system with software-based RAID, remember that extra CPU cycles are needed for the block device processing. We found that larger chunk sizes help. GPT-aligned partitions help quite a bit. And of course, if you want to buy our drives, that also helps me. For Robinhood tuning itself, we've found that disabling accounting helps significantly, although this may not be available for all users on all sites. It may be a requirement. Robinhood database threads should be based off of your findings from your Sysbench testing. Most of the larger scale machines that we've been running, we found that if the system likes 256 to 512 threads against the database, then we will limit it to about 256 threads and allow everything, Robinhood, the rest of the overhead. Client tuning is also important. There's various levels of caching that are on the client that for most of the Robinhood activity do not much good, because it's going to be kind of a once-off look at the file, and then after that you're moving on to the next thing. Increasing RPCs in flight, especially to the MDT, has helped significantly with performance. Tuning stat ahead for your workloads helps, and of course, flushing inode cache regularly so you're not hammering your memories too much. Some of the things that we've done as efforts to kind of improve Robinhood and its core performance in the areas that we're seeing as problematic have been code refactor work. Again, this includes taking the large logical blocks and kind of breaking them down into smaller functions, which just made it easier for us to manage and to program against. We're going to be introducing a new, well, I guess an extension to the existing plugin architecture so that this we can introduce plugins within the core record ingest and flow control systems within Robinhood. So this isn't a plugin like what Henri just discussed. It's more of a plugin system to allow for value-added components potentially within the core ingest from changelog itself. Part of that is we've introduced a couple of performance optimizations by a new plugin that we developed. The plugin itself will provide additional reductions in performance changelogs. So the plugin that we're working on right now is an algorithm. It's a changelog upload enhancement algorithm. Basically, what this does is it provides multiple duties. It will take the inbound changelogs, large swaths of inbound changelogs. It will sort them and categorize them. It will throw out anything that's unnecessary, and then it will provide us with a pathway to provide simplification of the SQL sets. The idea here is to reduce the number of transactions to the database as much as possible so as to reduce the overall load against our database, which is where we're seeing most of our slowness come from. Basic testing so far has shown that the plugin that we've got provides a reasonably good reduction in overall load on the system, as well as a pretty good reduction in load on the database itself. So some of the additional optimizations that we're working on and would like to continue to improve on as much as we can is SQL optimizations. Right now it's optimized for single transaction operations for the most part. It uses expensive and complex operations such as left join type queries, which require a rescan of the table space when you do them. It's pretty expensive. And this model tends to disallow sharding type horizontal scale operations where we have multiple tables or potentially multiple database systems handling handling the overall Robinhood database world. So one of the targets that we have here is to optimize these queries through our QProg plugin by introducing bulk operations as much as we can, reducing the total number of transactions going into the database, and simplifying things so that we're using more simplified delete and updates. Where in instead of multiple calls to the database for removal of information. We'd also like to provide a pathway here via this for additional database engines and technologies that may be out there. Right now, it's from what we've discovered based on our work, Robinhood is mostly focused on MySQL-based systems and has a lot of MySQL-isms in it, and that kind of prohibits us from moving to other database engines such as Postgres. So for us, next steps are to, test. One of the things we'd like to do is test multiple concurrent mounts with Robinhood. We know that, prior to recent versions of Lustre, FID lookups can be somewhat slow as they're serialized behind a single MDC semaphore. We haven't yet gotten to this point. We're not sure if we're going to actually perform this now that this issue has been mostly remedied in later versions. We'd like to consolidate the SQL query sets into batch transactions where possible. Further refinements to our new Q plugin. and we're investigating porting work to the alternative database engines, as I said, such as Postgres, TokuDB, and various NoSQL implementations, MongoDB and whatnot. So for the most part, this is what Seagate has been up to in the policy engine world. As I said, we are committed to continuing to provide updates and patches and whatever changes we need to ensure that this works well with our existing product line, and we plan to submit these updates back to the community shortly. So I know I spoke a little fast. Is there any questions?
Thanks, Colin. So do I understand that the plugins that you've created operate early in the ingest process, like maybe even right after you've acquired changelog entries?
I'm sorry, I'm having trouble hearing you.
Sorry. The plugins that you've introduced, or rather the place where they can be run, does that happen in the ingest after the changelog is read, but before anything else is done with them? Like, for example, before stats?
Yes, it's during changelog read is where we're targeting. As we see it, there's even with some of the patches from Cray that provide kind of a cleanup of the inbound changelog stream, there was room for improvement there. So rather than taking what was there and just simply modifying it, we thought, well, if we're modifying it now, we might want to modify it additionally in the future, depending on potential changes within how changelogs are processed. So we've introduced this plugin architecture here.
Did you by any chance introduce something similar in the scan process?
Not yet. We haven't targeted the scan process, as there's various other ideas to potentially speed this up. Our primarily focus was ongoing operations, as this is where most of our customers have complained. It's once Robinhood starts to get behind, then you have to rescan, and we would just like it to not get behind.
With the Q plugin, I'm just sort of curious the degree, if you have a feel for the upper limit of the number of files that you're able to handle with this.
I'm sorry.
With the number of files, if you have an idea of the upper limit of the number of files that you've been able to handle with these additional increases in speed.
No, we haven't. The limits are imposed by total file system size are still based off of database size. So additionally, as we refine the algorithm and the plugin further, we plan on potentially exploring the sharding techniques, which is one of the big reasons why we've engaged in this activity, so that we can push that up, horizontally scale the database rather than what you're stuck with now. Any other questions? Thank you, guys.